So please meet Yulia, and yeah.
Hello. So the topic of this talk is a quick guide to RPC frameworks, but I have only 10 minutes, so I can't fit everything that I want to tell in this time range. And I'll be focusing mainly on gRPC, so sorry about that. Let's start with defining our terms, so everyone will be on the same page. What is RPC? RPC is a remote procedure call. It means a protocol which one program can use to call a service from another program located somewhere on another machine on a network. It's mostly used for system-to-system communication. Although the concept is not new at all, it's actually more than 50 years old. But recently it started to gain more and more popularity among web developers community, together with microservices and other distribution systems concept. Here comes a story on why, in the first place, did I decide to give this talk. The deal is that for the last 2 years, I work on a big project. This is a distributed system. And it was using a RESTful JSON API for internal communication between services. And we decided to migrate the system to RPC-based communication solution. Here is a schema. How did it look before the change? That's actually a simplified version, because in real life it consists from more than 50 services, and here just some basic examples. So here you can see AWS Lambda. It sends some RESTful JSON to the entry point here, and all other services are connected via RESTful JSON. Okay. We are RESTful JSON. Also, we have NAS streaming as a messaging queue, and all those services are sending and receiving data from each other. And this, how does this system looks right now? So you can see RPC server as the center of communication. It connected. Also, we changed our stack, and now we are using Amazon Active Messaging Queue as our queue. It's right here. So some might say that we are added RPC interface in front of our queue. And all our services are now connected via RPC and using Proto for serialization. But why? First of all, it's performance, because we switched our serialization protocol, and now we are using Protobuffers, which is faster compared to JSON or XML, for that matter. Also, latency, because basically what we need is to send messages to our services directly, and we wanted to have a keep alive connection without round trips and proxy service, just direct messages to each other. And another reason is simplified versioning, because right now all our services have shareable schema definition, and it simplifies support and backward compatibility as well. We need to understand that RPC frameworks usually are not monolithic at all. They consist from multiple technologies, and they usually provide you options to choose from. So you can choose different technologies as a transport, or choose different serialization protocols. In 2019, there are quite a lot of RPC frameworks, like gRPC, Twirp, Thrift, Proto, FineAngle, Dubo, Avro, and this is a question which one to choose, but I will not focus on this today. And it's, by the way, quite interesting that most of the frameworks are baked up by big companies. Like gRPC is coming from Google, Twirp is from Twitch, Thrift is backed up by Facebook, FineAngle is from Twitter, Dubo is from Alibaba, Avro is a part of Hadoop project, and well, Proto is kind of stands out from this. So gRPC, this is the one, the most trendy right now, and well, I think the most popular still is Thrift, but everyone around me at least are using gRPC, and well, so we will be kind of paying attention for this one and check what are the benefits of this exact framework. It is available in those implementation, so there are blessed 4. Java, Golang, Python, and C++. Those are technologies who receives the updates, all security fixes first, and all the rest are kind of, when developers have a time, they receive their updates. Like on my project, when we were migrating from Ruby 2.5 to Ruby 2.6, we had an issue with Protobuf library, and we were waiting like maybe 2 weeks or so till they released an update. 2 weeks is still, you know, not too long, but still you can keep this in mind. gRPC comes with those options as a transport available. So here is a HTTP2. Coronet is a network stack for Android. And in process, it means that when you have server and client in the same process, you can send messages directly without serialization and deserialization. Protocols is about available serialization options. The most popular is Protobuffers, but also flood buffers, Cap and Proto, Thrift, JSON, and raw bytes are supported. We will look with more attention on Protobuf, like why is it more efficient than JSON, for instance. But first, we need to know that Protobuf is cool because it guarantees type safety and backward compatibility, and it's faster in terms of serializing and deserializing, and also it takes less space compared to XML or JSON. Here is a Proto file example. Here you can see messages structure and service definitions in terms of which messages it accepts and which types it returns in response. Proto buffers comes together with a proto compiler, which compiles after generates the code for you based on this proto file. So you will receive after generated classes for serializing and deserializing your data. Here is a capture from Wireshark. Here you can see a simple HTTP response with a JSON object. JSON object consists of content key and hello world as a value. You can see that the file data is 25 bytes. And let's compare it to gRPC Protobuf version. Here, the message data itself is 13 bytes. So it is lesser compared to HTTP. But also you can notice that it sends much more other service messages like settings, headers, pings, and so on. So might be for your system it doesn't make sense to migrate to this approach in case if you send messages or requests rarely and your data is relatively small. But if the messages are frequent and you have a reasonable amount of data, then probably you can consider this option. For pros, I can name great documentation, big community. HTTP2 is also a new cool technology. And the killer feature, which kind of highlights gRPC, is full duplex communication. As far as I know, it's a single framework, RPC framework, which supports it. And when it comes to the cons, you can see really a big amount of bugs there in their GitHub repo. And also I can name scaling and load balancing, because it uses HTTP2, and most of Amazon load balancers can't work with it yet. So it comes together with some specific load balancers from Google. I made a few code samples. They are not only for gRPC, but for some other RPC frameworks, and generally they are pretty similar, all of them. And here are some useful links so that you can find interesting information about other RPC solutions and can pick something which fits for your needs. And that's it. Thank you.
Thank you.